So in this video, we'll be going through saturated, unsaturated, and supersaturated solutions and seeing the difference between them. So first of all, let's look at some definitions. And one thing you need to know is the solubility of a solid in water. So what does it mean to have a solubility of an element in water? That means how much of an element can dissolve in water at a specific temperature. So let's see this example and it will make more sense. So here it says the solubility of boric acid in water is at 30 Celsius is 6.35 grams per 100 grams of water. So it basically means at 30 Celsius 6.35 grams of boric acid will dissolve in 100 grams of water. And if we add, let's say, 10 grams, that 3.65 10 minus 6.35 will not dissolve. So here it says any extra boric acid will not dissolve. And now let's look at the definition of saturated and unsaturated. So a saturated solution basically means that it contains the maximum amount of dissolved solute at the given temperature, which basically in our example means, let's say if we have dissolved 6.35 grams, or let's say 6.34 grams in 100 grams of water at this temperature, so it would mean that that solution is saturated. If it's any less than the maximum amount, let's say 3 grams dissolved, so that will be unsaturated. And for supersaturated, it's a little more different. So let's say we have a solution at 30 Celsius and we dissolved 6.35, and now we lowered the temperature to, let's say, minus 30. And if that solution stays in contact, so if it does not show any residue, that means it's supersaturated. So we'll look at an example and this will be more clear. So this is an example, so let's read it. So solubility of sodium acetate in 100 grams of water is 119 grams at 0 Celsius and 170 grams at 100 Celsius. So it is telling us that 119 grams will dissolve in 100 grams at 0 Celsius, and if we 170 grams will dissolve at 100 Celsius. So now let's look at a question. So it is saying that if 170 grams of sodium acetate is placed into 100 grams of water, so we need to see the temperature and the grams of water also at 0 Celsius. So at 0 Celsius, this is the solubility and the maximum is 119. So only 119 will dissolve and the rest will remain as the residue. So for A, if I write it here, so only 119 grams will dissolve and the rest of 151 grams will be left as the residue. And is the solution homogeneous or heterogeneous? This is very simple. So if you have any solids like residue, it means heterogeneous, and if we don't have any residue, then it's homogeneous. So in our case, it's going to be heterogeneous. So B hetero, and then C is asking if it's saturated, unsaturated, and supersaturated. So we reached our maximum amount of dissolved solvent, so it is saturated, which is 119. So we reached that and it's going to be saturated here. And now you have to be very careful here. So now it's saying that if this solution is then raised to 100 Celsius, will the mixture be homogeneous or heterogeneous? So at 100 Celsius, it can dissolve 170 grams. So in our case, it's going to dissolve everything. So if it dissolves everything, it's going to be homogeneous. So we can write that here, the homogeneous. And then what is the next question? E is going to be again saturated because we dissolve the maximum amount, which is 170. And then F is saying if this system is okay. So now this is going to be the supersaturated question. So whenever it is saying like the solutions then being cooled back down to 0 Celsius, so that's going to be related to supersaturated. So in our case, it's saying that it's cooled back down to 0 Celsius and no crystals, so basically no residue appear in the system. So in our case, this is gonna be, first of all, it's asking if it's homogeneous or heterogeneous. So if there's no residue, then it's homogeneous. Homogeneous. And then F is gonna be supersaturated. As we talked about it before, if you cool a solution back down to the less temperature and there is no residue appearing, this means it's supersaturated because it's holding more than it is supposed to. So if it's holding 170 at 100 Celsius, and if you go back to 0 Celsius, that 170 is still being held, still being dissolved at 0 Celsius, but it's supposed to dissolve only 119 grams. So that's why we say it's supersaturated. So in this example, it's a little more tricky. So you could pause the video and try to do this yourself. So here the solubility of InCl3 is given as 2116 grams per liters. So these units are very important in water at 20 Celsius, and it's asking us to categorize each solution below as unsaturated, saturated and supersaturated. So now let's read it. Solution 1. 4.001 grams is completely dissolved. So this is very important also. So let me just highlight this. Completely dissolved, meaning there is no residue. So now it could be supersaturated also if we find the solubility more than this. So just to keep that in mind. So now let's see this. Yeah, so completely dissolved in 2.742 ml of water. So again, very careful, unit here and liters here. So the thing we just need to calculate is the solubility, which is grams per liter. So we have the grams and we have the liters if after converting it. So let's do that now. So this is the equation, which is very simple as the solubility is given up here. So the answer that we get is 1459.15 and then blah blah blah. So this is definitely less than this. So we are sure that solution 1 is unsaturated. So let me just highlight this as blue. So this is unsaturated. Now let's check the next equation, which is next solution, which is 896.5 grams is completely dissolved in 423.7. So again, do the same formula. So let's see here. So it's gonna be, okay, let me just remove all this. So we do the same thing here to convert it to this units, and we get 2115.88, which is very close to this. So this has to be saturated. So let me just highlight this as saturated then. Yeah, now let's try the next equation, which next solution, which is 17.12 grams is completely dissolved in 6.744 ml. So use the formula again, same thing. So we get the answer of 2535, which means that it's holding more and it's completely dissolved, which means there is no residue. So it has to be supersaturated. So let me just make this into, yeah, and now finally the last solution, which is 1.699 times 10 to the power of 6 divided by 741.6 divided by 1000 to convert it to liters, and we get a huge answer here actually, which is let me just write it, 2290992, which is way more than this. So solution 4 has to be supersaturated again, because it here also says that it's completely dissolved, but there should be this much residue, so it has to be supersaturated. So let me just change this to this, and yeah, so that's all for this video. If you have any questions, you can ask in the comment section below and I'll answer them.